Hello guys, welcome back to Maison African Motives, still on Mathematics N5. In this platform, we shall be working on integrals, that is the integration part that we have in our syllabus. So we've got question number 4 of April 2020 that we are going to focus on. We are given questions on integration and also the last part on 4.2, that's 23 marks, everything on integration. So we shall quickly rush through the questions so that we can see how we're supposed to answer these typical questions. So quickly rushing through, we are given to determine the integral of y with respect to x in each of the following cases. So these are expressions or terms representing y in terms of x. So we need to find the integrals of these. Okay, so let us quickly rush through the first part of the question, which is on 4.11. Okay, let me just try to reduce this, guys. It's too much. Okay, let me just do this. All right, so this is question 4.11, where we are given the integral of y, of which y was given as 4 over that was sec x. Okay, like this. This is sec x, and multiplied to e to the exponent of sine x. All right. So this is the integral that we are going to do with respect to x. So take note, let's just cross-check, is it? So yeah, that's it. And that's 3 marks for that. Okay, so what can we do in this case, guys? How can we integrate this part? Okay, if we are to check, we have got two combinations that we have. We've got a trig, the part of sec, an exponential, also carrying a trig, which is the part of sine x. All right, so in this case, we can try by all means to play around with the substitution method. It can actually help us. Take note, from our substitution method, we need to make u equivalent to a certain expression or a certain term in terms of x. Okay, so in this case, I'm going to take advantage of this sine x, which is on the exponent. Okay, so I'm just going to use that. Okay, so let, in this case, u be equivalent to the sine of x. All right, so that means I can find the derivative of u with respect to x, of which we know that the derivative of sine gives us the cos of x. Okay, so we know that from our substitution part, what we are supposed to do is to substitute dx here and u in place of sine x. So this is what is going to happen here. If we are to make dx the subject, this is same as over 1, so you can cross multiply. That's du is equivalent to the cos of x by dx. So to find the value of dx here, which means we have to divide by the cos of x here by the cos of x here. So this can cancel. So that means the expression that is going to represent dx, it's du over the cos of x. Okay, of which there's something very, very, very important about this du and the cos x. We can actually work with it as a cos x like this, or we can introduce 1 over cos x. 1 over cos, we know that it's sec. Okay, so let's just leave it for now like this. I'm gonna explain the other part later on. So that means we can substitute here. That's the integral of 4 over the sec of x. In this case, we've got e to the exponent of u. That means in place of sine x, we are now substituting u in place of sine x. Okay, by dx, of which our dx is equivalent to du over cos of x. So this is going to give us du over the cos of x. So we know that somehow we are supposed to cancel out if we have substituted like this, but we can see that this is not happening here. What is it that is happening? Because they were supposed to cancel somehow the cos and the sec somehow there. They were supposed to cancel each other. Okay, so what are we going to do, guys? We have got two options that we are going to do. Either we are going to change sec to cos, or we are going to change cos into sec. Either way. Why? Because we know that there is a relationship between cos and sec. This is the relationship here. We know that 1 over the cos of x is equivalent to sec x. So if we are given du over cos x, is the same thing as we have got 1 over the cos of x like this part here can be affected as 1 over cos x, which is going to give us sec x. So that means we can have the integral written as 4 over the sec of x e to the exponent of u by du cos 1 over cos x, which we said it's sec x. So this is going to give us sec x. Okay, so that's what you're going to have, of which this whole part is same as writing as over 1. It's just one and the same thing. So take note, guys, we changed 1 over cos to sec x. So when we see 1 over cos, it is going to be represented with cos x. So that these two can cancel. The sec x and the sec x can cancel. We are remaining with the 4 over e to the exponent of u, which is integrated in terms of u. But we know that if we are given a fraction like this from our exponents, let's say we are given, let me write it down here, x to the exponent of minus a, we know that is same as 1 over x to the exponent of a. So that means 4 over e to the exponent of u can be written this way. We can write this as the integral of, okay, let's write it aside here. We are going to have the integral of 4 e to the exponent of negative u, so that we introduce the negative. It's 1 over, so it's going to be to the exponent of negative u with respect to u. Okay, so there we can integrate properly because we've got e and this is an integral. Okay, how can we integrate e, guys? How do we integrate e with respect to u? Okay, we know that the integral of e is supposed to be, we find the derivative of the function that is affecting u here. The derivative in this case of negative u is -1. So that is what you are going to divide with. So it is going to be 4 e to the exponent of minus u like this. Then you divide by the derivative of that, which is a -1, plus the constant of integration, which is c. All right, so that's what you're going to have, of which we can interchange these, guys. Remember, previously we were given here, I want you to take back here, previously it was 4 over e to the exponent of u, which gave us e to the exponent of minus u. So which means we can rewrite this e to the exponent of minus u as it was previously here. All right, so that means if we are to write it as it was previously, we are going to have this as 4 divided by -1, that's -4. So it is going to be -4 here. Okay, let me just do this so that, okay, this is 4 here and -1. So it is going to be -4. Everything over e to the exponent of u plus the constant of integration. So take note, this was an integral which was with respect to x in this case. So that means we are supposed to substitute back in place of this u that we are given on our final answer. We are supposed to substitute here the value of u. We said u is equivalent to sine of x. We are going to substitute the sine of x in place of what? In place of u. So this is going to be -4 over e to the exponent of sine x plus the constant of integration. So that's what actually we had from this part. So as you can see, guys, it's pretty clear. All you need is to work on much patience and revisions. This can actually help you guys as you are preparing yourselves for the exams. All right. Let's check the other part of the question, which was now on question 4.12, and that is actually 3 marks. We're given to find the integral of, that's y with respect to x, and this is the value for y. Okay, so we are going to rewrite this question. Okay, I'm going to rewrite this question aside so that we can see what was supposed to happen here. All right, so this is question 4.12. So that's question 4.12. Okay, we are given to find the integral of this whole expression that was arc cos in bracket. All right, so it was arc cos of 2x in bracket to the exponent of 4, everything over the square root of 1 minus 4x squared. All right, so that's it with respect to x. All right, so you will see that most of the part, guys, that you're given, it's actually substitution. Most of the part is actually substitution part that you're going to apply. And in this case, from our substitution, we have to choose a path that is actually easier for us to work with and also to make the proper substitution. We know that from the derivative of cos of arc cos here, we can obtain something under the square root of this format. So that means we can make a substitution on this part of arc cos. So guys, know your integrals, okay? So from your formula sheet, everything is given. Some of these derivatives, actually, you'll be given all of them. So you know that, okay, let me just write it down so that we can take it here. If we are given the derivative with respect to x of arc cos, let's write it as f of x. This is what we have. Okay, if we are given the derivative of this, it is going to be negative. We find the derivative of f of x like this, everything over the square root of 1 minus f of x squared. Okay, so this is the formula that you are supposed to know. So it's going to be easier because we can tell that if we are to make this to be the u and we find its derivative, it's going to give us something of this nature, which is similar to what we have here in the denominator. So that enables us to cancel later on, because remember, the issue of substitution method is that we are going to cancel, just like what we saw on the previous question. Okay, so that's what you're going to have. So we're going to introduce let u be equivalent to arc cos of 2x, which means this part is now u. Okay, so remember what we did previously. We're going to find the derivative of u with respect to x, of which arc cos, we said if it is the derivative of arc cos, it is going to be minus the first derivative with respect to x, of which the part that is with respect to x is this function, which is 2x. So the derivative of 2x is going to be negative 2. We've got a 2 here, so we drop 1, which is going to be 1 times 2. Then we subtract 1. That will be x to the exponent of 0, which is what? Which is going to give us negative 2. Everything over the square root of 1 minus f of x squared. So this is your f of x, which is 2x. So it's 2x squared like this, of which 2 squared gives us 4. Then we raise x to the exponent of 2, which is x squared. So which is similar to this part that we saw here. And what we need is to make dx the subject. As usual, guys, we are supposed to make dx so that you substitute or you remove this dx with the equivalent value that you're going to have. So definitely here, you're supposed to cross multiply. So that's it. If we cross multiply, what we're going to have, it's going to be du by the square root of 1 minus 4x squared, which is equivalent to negative 2 times dx. So to find dx, definitely we divide by negative 2, which is multiplying. So this can cancel. So this is the expression, or this is the term that represents dx. So our dx is going to be equivalent to du by the square root of 1 minus 4x squared, everything over negative 2. Okay, so that's it, guys. We have everything that we need to substitute back into this integral. So this is going to be equivalent to the integral of, remember we said this whole part is represented by u. So that will be u to the exponent of 4. This whole part is u. So that's u to the exponent of 4. Everything over the square root of 1 minus 4x squared times dx. Our dx, we have our dx here, which is equivalent to all of this part. So this is the one that we are going to use, which is du by the square root of 1 minus 4x squared, everything over negative 2. Okay, so we can simplify this so that we can find our integral by canceling these two. The square root of this and the square root of this are the same. Negative 2. All right, negative 2 cannot cancel for the meantime. This negative 2 cannot cancel anything, so you can just write it outside of the integral. So technically, it's like 1 over negative 2, which is same as negative 1 over 2. Okay, so this we can write it as negative 1 over 2. The integral of what are we remaining inside? We are remaining with u to the exponent of 4 and du. So which is the with respect to u. So that means we are going to find the integral of this u with respect to with respect to u, that is u to the exponent of 4 with respect to u. So we know that our integral, we are going to add 1, then we divide by the new exponent, guys. Please know your integrals. You add 1 on the exponent, then you divide by that new exponent that we have. So it's going to be negative 1 over 2. So that's negative 1 over 2, which is going to be u. If we add 1, that's 5 over the new exponent, which is 5. So you're going to divide by 5 plus the constant of integration. So we can multiply. That's negative 1 over 2 times 5, which is 10 u to the exponent of 5 plus c. But take note, u was not part of the question. We introduced this u where we said let u be equivalent to, if you still remember at this part here, we said let u be equivalent to arc cos to the exponent of 2, arc cos 2x. So which means in place of u, we are going to substitute arc cos 2x, okay? So in place of u, we are going to substitute arc cos 2x. So it's going to be negative 1 over 10. Then we've got arc cos 2x like this. Everything that we have on arc cos is raised to the exponent of 5, okay? Plus the constant of integration. So that's what you're going to have at the end. And we saw that it was actually 3 marks for that. So guys, please make sure that you revise your integration. It's one of the most interesting topics that you have in your syllabus. Most interesting, because you just need to know what to work with. If you know what to work with, then it's going to be very easier in your syllabus, this topic. Okay, anyways, let's rush to question 4.13, which was actually having 5 marks. Okay, let's see, wow, how is that possible? 5 marks for this question. Okay, that was the integral of the whole expression. So I'm just going to rewrite this expression as usual. So that's 4.13. Okay, so we have got 4.13 in this case. Okay, so on 4.13, that is the integral of, so we are going to have the integral of, that was x to the exponent of 3 plus 2x squared plus 9x minus 17. Okay, everything over x plus 4. Okay, over x plus 4 with respect to x. Okay, so let's see, what do we have here? What can we do actually? So when you are given this type of a question, guys, make sure you understand how to apply your long division concept. Okay, that's where you are going to apply the long division concept. There's a typical question where you can actually do it by expressing by parts. This is not the typical question, because we can see here that in the numerator, actually, we've got lesser. The exponent that we have is very small, it's 1. So it can be divided into this expression. So we can't try to express this into partial fraction. That's a waste of time, because we just have 1 term in the denominator. We are not having 2 terms like linear factors or quadratic factors, this and that. We know our partial fractions, guys. So which means this is not the question that lies under partial fraction. This one, you are supposed to apply the long division concept. Okay, so I hope we are together there on long division. From your mathematics N3, we apply this long division. Okay, so you're going to divide x plus 4 into the whole expression of x cubed. So that's x cubed plus 2x squared plus 9x minus 17. Okay, so from our mathematics N3, guys, we said if we are dividing, always we divide the first term versus the first term. So that's the first term versus the first term. So x cubed divide by x, which is going to give us x squared. Okay, so that's x squared. Then whatever that you get here, you multiply back everything that you have in this bracket. So you multiply it as a bracket. So it's x squared multiplies everything here. So that's x squared times x, which is x cubed. X squared times 4, which is 4x squared. And after multiplying back, we subtract these 2 from the original expression that we had. Okay, so let's subtract x cubed minus x cubed. That's a 0 there. We move on to 2x squared minus 4. So 2 minus 4, that's minus 2. So that's minus 2x squared. And we know that the rest of the terms, we have to drop them down. So we are referring to 9x, we drop it down, 17, we have to drop these terms down. So that is going to be plus 9x minus 17. Okay, so at this stage, we are back again to that division. Always, guys, take note, it's first term versus the first term. So that's negative 2x squared divided by x, which is negative 2x. Then we multiply back negative 2x times x, that's negative 2x squared. Negative 2x times minus 4, which is negative 8x. Okay, after we've multiplied, what are we going to do, guys? We subtract, as we saw here, that we are going to subtract these terms. So from what we had, we are going to subtract. Okay, so what is the answer? Let me just indicate this where we are subtracting so that we know this was the answer after subtracting. So we're going to subtract here. So if we subtract, that's these two terms are the same, negative 2, negative 2. So if we subtract, that's a 0 there. Okay, 9 minus 8. Okay, so this is 9x minus 8x. So it's going to be a plus 9 plus 8, which is 17x. So that's 17x minus 17. Okay. We do the same, we divide, guys. 17x divided by x, that's plus 17 here. Then 17 multiplies back. So it's 17 times x, that's 17x. Then we multiply again 17 times 4. So if you multiply properly there, we are going to obtain positive 68. Okay. Then you subtract just like what we saw previously. All right. So let's see what you're going to obtain. 17 minus 17, that's a 0 there. Minus 17 minus 68. Okay. So if we are going to subtract, this is going to be negative 85. Okay. So let's see what you're going to. So when there is a remainder like this, you are going to write this way. Okay, let me indicate this number that we see, the negative 85 represents the remainder. Okay, if it was truly that you are dividing with x plus 4, let's say this x plus 4 was a factor. If you divide, this was going to give you a 0 here. But when you obtain a certain number, just like negative 85, it shows you are dealing or you are having a remainder in this case. Okay, so the whole of this expression is as a result of the combination of these two terms. When you divide by x plus 1 or by x plus 4, in this case, we are going to have this expression as, okay, let me write here. All right, so we actually obtained this later on. This is going to give us, okay, whatever that we had from that division that we had, that fraction over that fraction with respect to x. Okay, so I'm not going to rewrite that. This part, I'm referring to this part, guys. Yeah, here, I'm not going to rewrite this part. So from this part that you have, you obtained this, okay, which is after dividing by x plus 4, you obtained x squared minus 2x plus 17. So you're going to write this. It's an exact factor, this one. So you obtained exactly x squared. So this is going to be the integral of x squared. That was x squared minus 2x plus 17. Okay. After dividing, we got this as an exact term. But there is a remainder here that we indicated. There is a remainder of negative 85. So we are going to take that remainder, then we divide by, so it's negative 85 over the term that was dividing in the denominator here, which was x plus 4. So remember that we were dividing by x plus 4. So that's the term that you're going to use here, x plus 4. So this is the equivalent that you're going to have from the whole of that integral that we had. It's equivalent to this integral. So if it is equivalent to this integral, it's an advantage. Why? Because we can just integrate this, because it's easier for us to integrate this type of an expression. Remember your integrals, guys, what I said, you just have to add 1 on x, then whatever that you have, you add 1. So we're going to add 1 and divide by the new exponent like that. Okay, so on the first part, it is going to be to the exponent of 2 plus 1, which is 3. So it's x to the exponent of 3 over 3, minus, we move on to 2. So for 2, it was going to be negative 2x, okay, to the exponent of 1 plus 1, which is 2. Then we divide by 2. So 2 and 2, that is going to give us a negative 1. So it's negative x squared. That 2 and 2 canceled. 17 is a constant. So if we integrate, it is going to be 17x. Then we've got negative 85 over x plus 4. This is a fraction, and we know that it's going to give us a ln. So this will be negative 85 ln of x plus 4, okay, plus the constant of integration. Okay, so that's it. That's what you're going to have. So in the next class that in our next video that we're going to have, I'm going to try by all means to use this with the formula sheet at the same time, so that we can see from our formula sheet what is given and what is not given. But yeah, I'm just giving you the normal integrals that you're supposed to know. Even without a formula sheet, you're supposed to just know these ones by head. Okay, anyways, that's what we had. Then we move on to question 4.14, which is having 3 marks. Okay, so 4.14, it was the integral. We've got cos 3 pi x by cos pi x. Okay, so what type of integral are we going to do in this one? Okay, that's 4.14. Let's see here. Okay, let's see what we are given. So we are given on question 4.14 the integral of cos 3 pi x. So that was cos 3 pi x by cos pi x. Okay, cos pi of x with respect to x. Okay, I want you to note on this one very, very carefully. If we are to check here with cos on the first part, it's cos on the second part, but these two are different. So there you are supposed to work out with the identities, okay? So please, guys, know your identities, okay? So we know that from our identities, the product of cos, if we are given cos A multiplied to cos of B, this is going to give us half. Then for the cos, we are going to add the 2, which is going to be cos A plus B. Then we are going to have plus cos of A minus B. So please, guys, know this part. Also it's given in your formula sheet. So it's just a matter of applying the identity directly in your formula sheet. It's given like this. Okay. So what we need is to rewrite these in terms of this format. So we can note that this can be our A and this can be our B. So make sure that your A is a bigger term, B is the smaller term, okay? So compare 3 and 1 here, 3 is bigger than 1, okay? So that means we can substitute here this whole expression of cos 3 pi x by cos pi x as half of, as we saw that this is going to be the cos of A plus B, which is 3 pi x like this. That's our A plus B, our B, it's pi x, okay? Then we move on to plus cos A minus B, which is our A is 3 pi x. So it's going to be 3 pi x minus B, which is pi x like this, okay? So if we are to simplify this identity, guys, we are going to obtain half of, so this is going to be half of, we combine everything here. So if we combine, it's 3 plus pi x. So this is like 1 pi x, 1. The same here, it's 1. So it's like if you combine, it's just 3 plus 1, which is 4. So it's going to be cos 4 pi x plus cos, yes, going to be 3 minus 1, of which 3 minus 1 is 2. So that will be 2 pi x, or like this. Okay, so this whole part or this whole trig that we have here is the same as this trig that we had, which was difficult for us to integrate direct. So instead of integrating this, we are now going to integrate the equivalent, which is this answer here. So it's easier for us to integrate this part. As we can see, this is just a normal course that we are used to, okay? So that means we are going to have this as the integral of half. We can even write it out of the integral. It's a constant. So it is going to be cos 4 pi x plus cos 2 pi x like this, okay? Everything with respect to x. Okay, remembering that if you are integrating cos, guys, it's going to give us a sign. Remember, cos is just the reverse of sine. But if you are given this way, please note the integral of cos AX like this with respect to x is going to give us sine AX, so it's sine AX over A plus the constant of integration, okay? So in this case here, we are going to have our answer as a half then we are going to have sine, its cos is going to change. So this is going to change into sine 4 pi x, but we divide by a. A is the coefficient of x, and the coefficient of x is the number that is affecting x, which is 4 pi. Here it's 2 pi, but on the first one, it's 4 pi. So we're going to divide by 4 pi. The same thing here, plus sine 2 pi x, we divide by the number that is affecting x, which is 2 pi. Everything, we add the constant of integration. Okay, so that's it. We can choose to leave your answer like this, or you can choose to multiply each and every term by half, because half is out of the bracket. So it's 1 times sine 4x, which is sine 4 pi x, over 2 times 4 pi, which is 8 pi. Okay, remember, numerator times numerator divided by denominator. Okay, plus 1 times sine 2 pi x, which is sine 2 pi x, everything over 2 times 2 pi, that is going to be 4 pi, plus the constant of integration. Okay, so you can choose to leave your answer further like this. So these are the typical questions, guys. Very, very interesting questions, but you have to work on these questions as much as you can. Please, guys, do revise your past exam papers as much as you can. Then you'll see that you are simply redoing the same thing throughout. Okay, 4.15, still on integration. We are now given the integral of x by the square root of 1 plus 2x. Okay, so what are we supposed to do in this one, on this typical question? Okay, let's just write it aside as usual. So we had 4.15. Okay, that was the integral of x into the square root of 1 plus 2x. So that was 1 plus 2x with respect to x. Okay, that's a product of the two. So normally, if you are dealing with a product, the first thing that you think of is actually by parts. Okay, that's the first thing that you think of. But in this case, it's a little bit different because if we are to check here, we can rewrite. Remember, square root, guys, from your laws of exponents simply means to the exponent of a half. So this is the same as writing as x by 1 plus 2x to the exponent of a half, like this, of which we can try and play around with this idea. We can play around with 1 plus 2x, make substitution back to our substitution method. Okay, there can be so many ways, guys, that you can use to integrate. If you have any other method, then on the comment section, let me know so that we can work on with that type of method in the next videos for others to also benefit. Okay, anyways, so in this case, it was very, very much easier if you would have used substitution method, because you're just going to introduce u to say, remember our substitution, let u be equivalent. I'm going to choose 1 plus 2x. So if u is equivalent to 1 plus 2x, remember we need the derivative of u with respect to x, which is 1 is a constant, so that's a 0 there. Then we've got 2x here, the derivative of 2x, which is 2. Then we make dx the subject, we can cross multiply. That's du is equal to 2 times dx, which is 2 dx. Then we divide by dx by 2, sorry, to make dx the subject. So that means our dx is going to be du over 2. So we have got the part of dx here and our u here. So this is what you're going to do. We have to substitute back into the formula. So that's going to be the integral of x. Then we've got 1 plus 2x. The whole of 1 plus 2x is now represented by u. So that's going to be u to the exponent of a half. Then in place of the dx here, we're supposed to have a dx. So in place of dx, it is going to be du over 2. So that's du over 2, like this. Okay. Of which it's a much complicated way to work with, because still there is x and there is also u. This type of a question, I want you to understand this, guys. Okay, I want you to be very, very careful. We can see that we are supposed to find the integral with respect to u. Okay, here we have got u, but here we've got x. And we can't even cancel out, just like what we did previously on those substitutions that we did. We remember we're canceling the numerator versus the denominator. But now it's very, very impossible. So what are you going to do? You cross-check back to where you made the substitution here. can you make x to be the subject in terms of u so that you can substitute in place of x? Because here, this is a substitution of u that we made in terms of x. So can we make x the subject from this also? Can we make x to be the subject? Is it possible? Let's try. So if you are to transpose 1 to that side, is going to be u minus 1 is equal to 2x. We divide by 2 by 2. Yes, we can make x this to be the subject. So x in terms of u can be written as u minus 1 over 2. That's x in terms of the same u that we had. Remember, what we need is to remove this x, but we do not have a way of removing the x. So we go back to where we made the subject in terms of x, so that we now make x the subject of the formula. So that means in place of x, we are going to substitute u minus 1 over 2. That's in place of x here. So this is our x. We are going to substitute. So this is going to be the integral of, remember, we said in place of x, we now have u minus 1 over 2. So that's it, guys. As you can see, our answer now is just in terms of u. This is u to the exponent of half, and this is du over 2. So this is exactly what we need, because it is supposed to be an integral in terms of u on this part, because it's written du. Okay, so let's combine the terms so that we can integrate. What can we do? We can actually take this is over 2. This over 2 can be taken outside of the integral. It's a constant. So 2 times 2, that's 4. So this is going to be 1 over 4, because this is in the denominator. 2 is in the denominator, so it's going to be 1 over 4. Okay, then we remain with the integral of, take note, u to the exponent of a half is same as over 1. So which means we can actually multiply this bracket. That's u to the exponent of a half times u, or we are now back to the laws of exponents. You are multiplying u to the exponent of 1 times u to the exponent of a half. So you add the exponent because the bases are the same. So that's u to the exponent of 1 plus a half, which is 3 over 2. So we are going to remain with the integral of u to the exponent of 3 over 2. Okay, we do the same here. We multiply to expand the bracket, that u to the exponent of a half times this minus 1. So if you multiply, that's going to be minus u to the exponent of a half. So that's what we have, and we remain with du. Take note, the 2 are already out of the, we multiply these together, 2 and 2. This is the one that gave us this 4. So it's 1 over 4. Okay, so we can integrate, guys, properly. This is a normal integral that we are used to. So we know that if we are integrating, what were we supposed to do? We add 1 on the exponent, then whatever that we have, we divide by the new exponent. So let's just try to rewrite these ones aside. So this is going to be, if we add 1 here, 3 over 2 plus 1, that's going to be 5 over 2. So it's going to be u to the exponent of 5 over 2 over 5 over 2, like this. But remember, this is same as 1 divided by 5 over 2. And that's the inverse of 5 over 2, which is going to be 2 over 5. Or you can divide on your calculator. 1 divided by 5 over 2, that's 2 over 5. Okay, so this is going to give us 2 over 5 u to the exponent of 5 over 2, minus, you do the same here on u to the exponent of a half. If you add 1 here, that's going to be u to the exponent of 3 over 2. You divide by 3 over 2, which is same as 1 divided by 3 over 2, which is 2 over 3. So that's minus 2 over 3 u to the exponent of 3 over 2. So that's it, plus the constant of integration. Okay, so at this stage, we can now substitute our u, because remember, we said u is equivalent to 1 plus 2x. So in place, we are not substituting, we are not using x now. We are back to the u, because our answer is supposed to be in terms of x. So we are now substituting u, which is equivalent to 1 plus 2x. So in place of u, let's substitute 1 plus 2x. This is going to be 1 over 4 into 2 over 5. So this is 1 plus 2x in place of u. So it's 1 plus 2x to the exponent of 5 over 2. Minus 2 over 3. We substitute in place of u, which is 1 plus 2x. So this is 1 plus 2x. Everything to the exponent of 3 over 2. Then we add the constant of integration. Okay, so you can choose to leave your answer at this stage, guys. This is fine at this stage. You can choose to leave your answer like this, or you can multiply back everything by 1 over 4. So that's 1 over 4 times 2 over 5, which is going to give us 1 over 10. So that's 1 over 10 into 1 plus 2x to the exponent of 5 over 2 minus 1 over 4 times minus 3 over 2, which is going to give us negative 1 over 6 into 1 plus 2x to the exponent of 3 over 2 plus the constant of integration. Okay, so that's our final answer if you decide to expand the brackets. But if you do not want, then you can just leave at that stage, still fine. So these are most typical questions, guys. Be very, very careful when attempting these ones. Okay, anyways, let's see the other part of the question, which was, okay, that's supposed to be on the other page. So this was actually 4 marks, okay? Okay, 4 marks. So let's see the other part of the question on the other page. That is 4.2. Determine the integral of y with respect to x by resolving. Take note, you are given to resolve into partial fractions. We are given what to do to use partial fractions. Okay, so that's it, 4.2. Okay, so let's just put back our black sheet so that we get to the same thing we're using before. All right, sorry for that, guys. Very, very sorry for that. Okay, so that's it. 4.2 we are given in this case, so that's 4.2. So it's going to be the integral of 3x. So that's going to be 3x over 2x plus 1. So we are given 2x plus 1 into x plus 4. All right, so that's it with respect to x. So we're given to resolve into partial fractions. So if we are to check, guys, into partial fractions, we can see that in this case, on the denominator, we actually have 2 brackets which are already factorized in factorized manner. So these are linear factors. So how do we convert into linear? So we know that this is going to be a over this plus b over that plus c over that plus d over that and so on over the linear factors. So we are simply saying 3x over 2x plus 1 into x plus 4 like this is equivalent to a over the first term, which is 2x plus 1 plus b over the second part, which is x plus 4. So all you need is to find the values of a and b. So how do you simply do this? Okay, this is, we are supposed to add this and that. So instead, just equate, okay? 3x here, which is in the numerator, is equivalent to a. So we're going to take a here. So what is going to happen? We're supposed to apply the normal addition, but guys, you know that this is going to cancel the 2x plus 1 and the 2x plus 1 will cancel. You remain with x plus 4. So you're going to have it as x plus 4 plus b. Okay, x plus 4 and x plus 4 you cancel, which means you remain with 2x plus 1. So it's going to be 2x plus 1 like that. So all you need is to find the values of a and b from this equation. So let's see from the first bracket, if we let this bracket of x plus 4 to be equal to 0, that means x, if we transpose 4 to the other side, is going to be negative 4. Okay, so when x is equivalent to minus 4, that means this whole bracket is equal to 0. We can eliminate that bracket, okay, when x is equal to minus 4. So we can substitute minus 4 in place of x here. That's 3 times minus 4 is equivalent. Here we substitute minus 4, so that's 2 times minus 4 plus 1. Okay, 2 times minus 4 plus 1, whatever that we get, we multiply to b. So 3 times minus 4, that's negative 12. 2 times minus 4, that's negative 8 plus 1. That's negative 8 plus 1, which is going to give us negative 7. So we are going to obtain negative 7b. So you can divide by negative 7 by negative 7. Okay, so let's find our b, guys. So this can cancel. So b is equivalent to 12 over 7. Okay, so we can do the same thing to calculate the value of a by equating the bracket of b to 0 there. So if we equate 2x, okay, sorry for that. So that's 2x plus 1. If it is equal to 0, that means 2x is equivalent to negative 1, x is equivalent to negative 1 over 2. So we are simply saying when x is equivalent to negative 1 over 2, that means this whole bracket is going to be equal to 0. Okay, so we move on to this part. We substitute 3 times negative 1 over 2 is equivalent to negative 1 over 2 plus 4, then multiplied by a. So 3 times negative 1 over 2, that's negative 3 over 2, which is equivalent to, if you add properly here, guys, I want you to add, that's going to give you 7 over 2a. Okay, so to find a, definitely you divide by 7 over 2 both sides, by 7 over 2 both sides. So this can cancel. So our a is going to be negative 3 over 2 divided to 7 over 2. Put this 7 over 2 in a bracket like this, okay? This is going to give you negative 3 over 7. All right, so I've got the values of A and B in this case, okay? So here is our A, and we've got our B here. So you're going to substitute these now into the part that we converted here into partial fractions, which is we are going to substitute here in place of A and in place of B, okay? So that's what you're going to have at the end. So take note, this is going to be the integral of, okay? So we are going to have this as the integral of, that was A over, this is, take note, A over 2x minus 2x plus 1. So our A in this case is minus 3 over 7. So if we substitute minus 3 over 7, it's going to be like this, minus 3 over 7. So this is going to affect this whole part here, okay? So that is how you're actually writing it as, okay? So that's minus 3 over 7, like this. It's going to be minus 3 over 7, okay? So you can just write that part, which was 2x plus 1 like this, okay? That's it, 2x plus 1. Then plus b, our b is 12 over 7. So it's going to be the same thing. So it's going to be plus 12 over 7 into the denominator, which was x plus 4. So that was x plus 4 like this. So we integrate this with respect to x, everything. Okay, so for you not to confuse, guys, it's just the same way as writing like this. It's the same way as writing like this, minus 3 over 7 like this. The integral of, you remove this 3 over 7, negative 3 over 7. So what do you remain with if you remove this? You remain with 1 over 2x. So it is going to be 1 over 2x plus 1 like this. You integrate this. You move on to the same thing. If you remove this 12 over 7, what do you remain with? You remain with 1 over x plus 4. So it is going to be plus 12 over 7 out of the integral. Then you remain with 1 over x plus 4 with, so that you can integrate properly without these constant terms and so on and so on. Okay, so what are you going to have here? It is going to be negative 3 over 7. Okay, then we integrate 1 over 2x plus 1. So remember, guys, if you are integrating, if it is written as the integral of, we put 1 over ax plus b with respect to x, remember our answer is 1 over a ln of ax plus b. Okay, so our a in this case is this number that is affecting x, which is 2. So our answer is going to be 1 over 2. So this is going to be 1 over 2. Then we've got ln ax, which is ln this part as it is, which is ln 2x plus 1. Okay, so that's it. Plus here for 12 over 7 times 1 over x plus 4. The derivative here is 1, so there's nothing that we're going to have. So it's just going to be ln x plus 4 plus the constant of integration. So that means we can just expand these brackets that we are having. Negative 3 over 7 times 1 over 2, that's negative 3 times 1, which is negative 3 over 7 times 2, that's 14, and we remain with ln 2x plus 1. Okay, we move on here, we just have to combine, so it's just plus 12 over 7 ln x plus 4, we just combine like that. There's nothing that you can do further here. All right, so that was the final answer that you're going to obtain. Negative 3 over 14 into ln of 2x plus 1 plus 12 over 7 into ln of x plus 4 plus the constant of integration. Okay, so that's what we had, guys, on this integral by parts. By expressing into partial fractions. So you can be given these typical questions. So be very, very careful, guys, how to attempt these questions stage by stage. You won't miss any mark if you do that. Okay, so that's what we had, guys, for Meso-African motifs, still on mathematics N5, till we meet again.